Welcome to lesson 5.3. This lesson is about using graphs of the first derivative to answer questions. And here's the important part. With justification. These answers always have answer because, and then you justify why that's the answer. Now, a couple things to note. First off, it is very important that in your justification, you reference the given graph by name. Stay away from words like it. You don't want to use words like that. What is it? You need to describe that. And it is unnecessary and unwise to write more than one sentence of justification. Gary said that when he was grading tests, he often found that the first sentence was correct, but then if students wrote more than one sentence, they would contradict themselves somewhere in it, and then they'd lose points. So this kind of problem, it's really smart, just one short justification sentence. Now, another thing, it will be helpful to draw our number lines, our sign lines. However, those do not count as justification. They just help you get the answer right. So let's look at an example of this. The graph below is a graph of f prime, the derivative of f. The graph of f prime has, this is important, horizontal tangents. Now remember, if I have a horizontal tangent line, that means the slope is 0 because it's horizontal, which means the first derivative, or I should say the derivative of it, is 0. So in this case, since this is the graph of f prime, horizontal tangent lines would mean the second derivative would be 0 at those points. It's also just a shortcut for saying maxes and mins, extrema. So we have a maximum at -2 and a minimum at +2. So let's start to analyze this. Question 1. On what open intervals is f increasing? So let's start with our number lines that we got so good at in the last chapter, in the last couple sections. Labeling them. So first off, f prime number line. This is the number line of this graph. So not increasing and decreasing, we're just talking about where is this graph positive, where is this graph negative. Well, it looks like at -4, it changes from negative to positive. Then at 0, it changes from positive to negative, above to below. And then at 4, from negative to positive. While we're at it, let's make an f double prime number line as well. Now this is the derivative of the graph we're looking at. So this is slope of what we are looking at. So now we're talking about increasing and decreasing. Where is the slope of this graph positive? Where is the slope of this graph negative? So it looks like up to -2, that slope is positive. From -2 to +2, the slope is negative. And from 2 on, that slope is positive again. So now let's go back to number 1. On what open intervals is f increasing? So now we're talking about the original. Where is the original increasing? Which would mean where is the derivative positive? If we want to find where the original is increasing, we want to look where the derivative is positive. So if we look at our number line, the derivative is positive from -4 to 0, and I'm doing open because that's what it asked for. And, oops, forgot to label that. And 4 to infinity. And now we need to justify. So we can say f is increasing from -4 to 0 and 4 to infinity because, I'm going to write all of these in green because that because is so important. Because. Now, in these because justifications, you should always reference what you're given, not what you implied. So we're going to reference this graph here because that's what we're given. So I know that f is increasing on these intervals because f prime of x is positive. I'm referencing the graph that was given to me. Okay? I want you to try number 2 on your own. Remember that justification. On what intervals is f decreasing? You can kind of use what we've done so far as a template. Pause the video, try writing your justification sentence out for that one, and then come back and see how you did. Welcome back. Check what you got with what I got. I said f is decreasing from -infinity to -4 and 0 to 4 because f prime is negative, referencing what I've been given. Okay, what values does f have relative extrema? So where does the original have maximums and minimums? So this is where f prime is going decreasing, increasing, decreasing, increasing. So it looks like we should have a relative maximum at 0. So f has a relative maximum at x equals 0 because, reference what we're given, f prime of x changes from positive to negative. So I know it's a maximum here because f prime is changing from positive to negative. That's what tells me it's a maximum on the original. Okay, once again, using that as a template, try number 4 to find where there's a local minimum. Check what you got with what I got. F has a local min at x equals -4 and +4 because f prime is changing from negative to positive. That's how I know, referencing what I've been given. Okay, next one. On what intervals is f concave down? So the original is going to be concave down. So we've got concave up, concave down, concave up. So it looks like from -2 to +2. So f is concave down from -2 to +2 because, now this because is a little tricky. We can't say because f double prime of x is negative. That doesn't work because that doesn't reference what we have been given. We have to reference f prime because that's what we're given. So we have to say because f prime of x is, what is f prime of x doing from -2 to +2? Well, is decreasing. I know f is concave down because f prime is decreasing. I'm referencing what I've been given. Okay, where does it have points of inflection? I want you to try this one on your own. Once again, be careful on your justification. Make sure that you are justifying with what you've been given. Ready, set, go. Welcome back. Let's check what you got with what I got. F has a point of inflection at x equals -2 and +2 right there. That's where my concavity is changing. Because, reference what I'm given, f prime of x changes from increasing to decreasing or from decreasing to increasing. Make sure you have both options. If you only say because f prime of x changes from increasing to decreasing, you will lose points because that's not the only place where a point of inflection occurs. It has to be either or. Now, you can word that in a couple different ways. You could say from increasing to decreasing or vice versa to shorten it a little bit, things like that. But make sure you include both instances. Okay, last question for today. On what intervals, excuse me, is f both decreasing and concave upward? So, let's start this one out. F is decreasing and concave up from, okay, let's look at our number lines. Decreasing and concave up looks like right there from negative infinity up to -4. And let's see if there's another one. Decreasing and concave down right there. Decreasing and concave up right there. And from 2 to 4. Because we're decreasing there, concave up there. There we go, right in there. And now we need to do our because, and we reference what we know. Because f prime of x is negative, that means decreasing, and concave up would be where f prime is increasing. So I know the original is decreasing because the derivative is negative, and the original is concave up because the derivative is increasing. We're always referencing what we know, what's been given, not our number lines. So that is it for this lesson. You should be able to get started on your homework.